Euler's theorem. The link is given in the description. You can watch and share that video to your friends. And that is a prerequisite for this series. Now we start with Euler's theorem for homogeneous function of first order partial derivatives. If u equal to f of xy is a homogeneous function of degree n, then x dou u by dou x plus y dou u by dou y equal to nu. So what is this n? N is degree of the homogeneous function f of xy. Similarly, we extend this to three variables. Then this is x dou u by dou x plus y dou u by dou y plus z dou u by dou z equal to nu. So we start with the first problem, that is algebraic function. If u equal to x power 1 by 4 plus 1 by y power 1 by 4 divided by x power 1 by 5 plus y power 1 by 5, prove that x dou u by dou x plus y dou u by dou y equal to 1 by 20 u. First we will check the homogeneity. So what with that? We replace x with tx and y with ty, right? So then what will you get? Xt whole power 1 by 4 plus yt whole power 1 by 5 plus xt whole power 1 by 5 plus yt whole power 1 by 5. So for the numerator, take t power 1 by 4 common, and for the denominator, take t power 1 by 5 common, right? And so if this denominator t power 1 by 5 goes to the numerator part, so this will becomes denominator t goes to the numerator part, this becomes t power 1 by 4 minus 1 by 5 into x power 1 by 4 plus y power 1 by 4 by x power 1 by 5 plus y power 5. So this is u. So this is u, f of xy. And 1 by 4 minus 1 by 5, 1 by 20. So what we get? F of xt comma yt equal to t power n into f of xy. U is f of xy. So this n denotes the degree, right? So therefore the degree is 1 by 20. N equal to 1 by 20. By Euler's theorem, x dou u by dou x plus y dou u by dou y equal to nu. Since the n is 1 by 20, so 1 by 20 u. Since and here we are verifying the Euler's theorem for the composite function or the inverse trigonometric function. U equal to sine inverse of square root of x plus square root of y by x plus y. Show that x plus x dou u by dou x plus y dou u by dou y equal to, right, this is minus 1 by 2 tan u. Okay, so this is minus 1 by 2 tan u, not 1 by 2 tan. Since this is it involves the non-linear term, right? Therefore we must convert into auxiliary function, right? So let v equal to sine u, right? So applying sine on both sides, sine u equal to square root of x plus square root of y by x plus y, right? So this is f of xy. So we check the homogeneity, replace x with xt and y with yt. Then this is t power minus 1 by 2 into 1 by 5. So this is easy. How to find the degree? Numerator degree 1 by 2, right? Denominator degree 1. Since all terms have degree 1 and the numerator all terms have degree 1 by 2. So degree of f by g is degree of f minus degree of g. So which is 1 by 2 minus 1, which is minus 1 by 2, right? N equal to minus 1 by 2. So by Euler's theorem, we have x dou u by dou x plus y dou u by dou y equal to minus 1 by 2 v, right? Since v equal to sine v equal to sine u, right? So dou v by dou x equal to, since sine u is composite function, right? Since sine of u is composite function, u is function of xy, right? So sine u, differentiation of sine u with respect to x is differentiation of sine u cos u into dou u by dou x, because u is function of xy. Similarly, dou v by dou y is cos u into dou u by dou y. Substituting this here, x dou v by dou x plus y dou v by dou y equal to minus 1 by 2. So x dou v by dou x is cos u dou v by dou x from here, plus y dou v by dou y is cos u dou v by dou y equal to minus 1 by 2. V is sin u. Taking cos u common, so this is equal to minus 1 by 2 sin u. This is x dou u by dou x plus y dou u by dou y equal to, if cos u goes to the right hand side part, this becomes 1 by cos. So minus 1 by 2 sin u by cos u tan u. So minus 1 by 2 tan u. The third problem, that is the inverse trigonometric function. Same thing, if u equal to tan inverse of x cube plus y cube by x minus y, then prove that x dou u by dou x plus y dou u by dou y equal to sin 2u. Since this inverse in u itself is not homogeneous, therefore we must convert into an auxiliary function. If we convert this into auxiliary function, then we have used that theorem. X dou u by dou x plus y dou u by dou y equal to n times f of u by f dash of u. Right? So first we convert it to auxiliary function, apply tan on both sides. So v equal to tan u equal to, so tan of tan inverse, which is x cube plus y cube by x minus y. So how to find out the degree? Since the numerator all terms has degree 3, denominator terms has degree 1, therefore the degree, it is of the form f of xy by g of xy. Degree of f by g is degree of f minus degree of g, that is degree of f is 3, degree of g is 1, so which is 3 minus 1, which is 2. By Euler's theorem, x dou v by dou x plus y dou v by dou y equal to 2v. So now apply chain rule. Since v equal to tan u, dou v by dou x equal to differentiation of tan u secant square u into dou v by dou x. This is by applying chain rule. Now dou v by dou y equal to secant square u into dou u by dou y. Substitute this in the first equation and Euler's theorem. So x dou v by dou x is secant square u dou v by dou x plus y dou v by dou y is secant square u dou v by dou y equal to 2 tan u, 2v. So this is v equal to tan. So taking secant square u common, secant square u into x dou v by dou x plus y dou v by dou y equal to 2 tan u. So if it secant square u goes to the right hand side, goes to the denominator part. So x dou v by dou x plus y dou v by dou y equal to 2 tan u by secant square u. Simplifying, 2 tan u by secant square u equal to 2 sin u by cos u by 1 by cos square u. So this is 2 sin u cos u. So this is sin 2u. Logarithmic function, if u equal to log of x power 4 plus y power 4 by x plus y. And remember that, so this is composite function, right? We must convert in composite function, and that means this is non-homogeneous. U itself is non-homogeneous, but it will be converted to homogeneous function by converting to auxiliary function. So we already know the definition, log of something equal to t, that means that something equal to e power t. So we define the auxiliary function by applying exponentials on both sides. So e power u equal to x power 4 plus y power 4 by x plus y. So this equal to v. So how to determine the degree? This is the ratio of functions f of xy by g of xy. Degree of f by g equal to degree of the numerator f minus degree of g. Degree of the numerator 4, degree of the denominator 1. Therefore the degree is degree of the numerator 4 minus degree of the denominator 1. So this is equal to 3. By Euler's theorem, x, so we will apply to v only, right? By Euler's theorem, x dou v by dou x plus y dou v by dou y equal to nv. N means odd degree. So 3v. Now since v equal to e power u, so we'll substitute here. Since v equal to e power u, so therefore dou v by dou x equal to e power u into dou v by dou x, and dou v by dou y equal to e power u into dou u by dou y. Substitute this in first Euler's theorem. X e power u dou v by dou x plus y e power u dou v by dou y equal to 3 e power u. Taking e power u common, e power u into x dou v by dou x plus y dou v by dou y equal to 3 e power u. Dividing by e power u, we'll get x dou v by dou x plus y dou v by dou y equal to 3. So this is a problem regarding 3 variables algebraic. Since u equal to x plus y plus z by square root of x plus square root of y plus square root of z. Find x dou v by dou x plus y dou v by dou y plus z dou v by dou z. And here we will apply Euler's theorem for first order partial derivatives of 3 variables x, y, z. Since same, this is f of x, y, z by g of x, y, z. How to find the degree? Degree of the numerator minus degree of the denominator. Degree of the numerator, all are powers 1, and the degree of the denominator 1 by 2. So the total degree is degree of the numerator 1 minus degree of the denominator 1 by 2. So 1 minus 1 by 2, 1 by 2. By Euler's theorem, x dou v by dou x plus y dou v by dou y plus, since we are adding the third one because we have 3 variables, plus z dou v by dou z equal to nu. So n is 1 by 2. So here degree 0 function, right? Since if u equal to sin inverse of x by y plus tan inverse of y by x, or if any function involving the inverse trigonometric functions, right, then we will show that x dou v by dou x plus y dou v by dou y equal to 0. Since here we directly tells that how to find the degree, we replace t with tx and x with tx, y with ty, right? So if you replace here tx by ty, tt cancel, same function will be obtained. Similarly here also ty by tx, the same function will be obtained. That means, see here, right, f of x xt comma yt equal to sin inverse of xt by yt plus tan inverse of yt by xt. So we are getting the same function. That means this is u, right? This is u. So t power 0 into u. That means our degree of the homogeneous function n equal to 0. So by Euler's theorem, x dou v by dou x plus y dou v by dou y equal to nu, because n is 0, 0 into u. So this is 0. And this is another example with composite function with a degree n. So right, this x power n has degree n. So if, and this is the composite function, right? A function of a function, a function of a function, sine, and that this is algebraic, right? Then prove that x dou v by dou x plus y dou v by dou y equal to n. So first we'll find out the homogeneity, right, by replacing x with tx and y with ty. So this is xt whole power n into sine of yt by xt. So this is t power n, x power n into sine of, this is yt by xt, tt cancels, so y by x. So this is t power n, and this total constitute u, x power n into sine of y. So that means degree n. Since the function sine of y by x has degree 0, right, and x power n has degree n, therefore the product has degree n plus 0 equal to n, right? This is of the form f of xy into g of xy. Degree of, that means product of f and g, then degree of fg equal to degree of f plus degree of g. Since degree of f means, if you consider the first one, degree of x power n is n, and g, degree of g is 0, therefore degree of fg equal to degree of f, that means n, plus degree of g 0 is equal to n. By Euler's theorem, x dou v by dou x plus y dou v by dou y equal to nu. So here degree is nu. Same thing, this is also logarithmic with square degree function. Same thing. So here, same thing, we will apply exponentials on both sides. We get f of xyz, and this is of the form f of xyz by g of xyz. So same rational function, degree of f by g equal to degree of the numerator minus degree of the denominator. Numerator degree 2, denominator degree 1. So therefore degree of total degree is 2 minus 1. Numerator degree 2 minus denominator degree 1. So this is 1. Applying Euler's theorem. So this is x dou v by dou x plus y dou v by dou y plus z dou v by dou z equal to nv. So because n is 1, 1v. And also remember that v equal to e power u. So substitute here v equal to e power u. So we will get e power u into ux means dou v by dou x plus y dou v by dou is e power u into dou v by dou y plus z dou v by dou z is e power u into dou v by dou z, which equals to v means e power u. V means e power u. So simplifying that, taking e power u common, this is e power u into x ux plus y uy plus z uz equal to e power u. So that is dividing by e power u, will get x dou v by dou x plus y dou v by dou y plus z uz means dou v by dou z is equal to 1. Here we will discuss another example on Euler's theorem for second order partial derivatives. Since if u equal to sine inverse of, and this is a wrong function, the actual function is x plus y by square root of x plus square root of y. Since this involves the inverse trigonometric function, which is non-homogeneous, but u itself is not homogeneous, therefore we will convert into auxiliary function, right? That means v equal to sine u equal to x plus y by square root of x plus square root of y. So for this we will use Euler's theorem for first order partial derivatives, which is x dou v by dou x plus y dou v by dou y equal to n times f of u by f dash of u. So n means what? N is degree of the function x plus y by square root of x plus square root of y. Since degree of the numerator, since this is rational function, degree of the numerator, which is 1, degree of the denominator 1 by 2, therefore total degree is degree of the numerator minus degree of the denominator, that is 1 minus 1 by 2, which is 1 by 2. And f of u is sine u, right? F of u is sine u, because we converted into auxiliary function. Sine u is this, sine u by f dash of u, means derivative of sine u cos u, sine u by cos u tan u. So this is x dou v by dou x plus y dou v by dou y equal to 1 by 2 tan u, assume it as g of u. So by applying second order Euler formula for second order partial derivatives, this is x square dou square u by dou x square plus 2xy dou square u by dou xy dou x into dou y plus y square dou square u by dou y square equal to g of u into g dash of u minus 1. Calculating g dash of u, since g of u equal to 1 by 2 tan u, derivative of g of u is 1 by 2 tan u is differentiation of tan u is secant square u. Now substituting in this formula, this is RHS, substituting in RHS, g of u and g dash of u, g of u is 1 by 2 into g dash of u minus 1, this is 1 by 2 secant square u minus 1. So this is 1 by 2 tan u into, so secant square u is reciprocal of cos square u, so this is 1 by 2 cos square u minus 1. Taking LCM, so this is 1 by 1 minus 2 cos square u by 2 cos square u. So, and if this 2 cos square u multiplied with 2, so this is 4 cos square u, tan u by 4 cos square u, and 1 minus 2 cos square u equal to minus cos 2u. How? By half angle formula. Half angle formula, cos square u equal to 1 plus cos 2u by 2. That means 2 cos square u minus 1 equal to cos 2u. Multiplying with minus sign, so that becomes 1 minus 2 cos square u equal to minus cos 2u, which will be minus sin u cos 2u by 4 cos 2u. This is algebraic ratio of degree 1 by 6. Since if u equal to this, then prove that x dou v by dou x plus y dou v by dou equal to 1 by 6 into u. Same thing, this is a rational function. Therefore, degree of f by g equal to degree of the numerator minus degree of the denominator. Degree of the numerator 1 by 2, degree of the denominator 1 by 3. So the degree of f by g is 1 by 2 minus 1 by 3, which is 3 minus 2 by 6, 1 by 6. By Euler's theorem, this is x dou by dou x plus y dou by dou equal to nu. N is 1 by 6 u. And this is the summary of key concepts. So function f of x1, x2, so on xn is homogeneous of degree k if f of tx1, tx2, and so on txn equal to t power k into f of x1, x2, and so on xn. Right, same this. So this is Euler's theorem for first order partial derivatives of n number of variables, but written in a summation form. So this is x1 dou u by dou x1 plus x2 dou u by dou x2 and so on xn dou u by dou xn equal to nu. So common techniques for verifying homogeneity, right? For verifying homogeneity, we substitute x to 2x and y to t by auxiliary functions method. So when we'll use this, if the given function involves inverse trigonometric function or the composite function, u equal to sin inverse u, u equal to tan inverse v, or the logarithmic function, right? So we apply the Euler's theorem to v, right? How? So for suppose here u equal to sin inverse v, apply sin on both, so sin u equal to v, so v equal to sin. We will apply for Euler's theorem to v only. So and next we use chain rule to relative derivatives, right? So how? So that formula is x dou u by dou x plus y dou u by dou equal to n times f of u by f dash of u. So there we will use chain rule, right? Derivative of sin u is cos u into dou u by dou x if it is dou u by dou x. Simplify to get the result for you. So this is the shortcuts, right? If any function is of the form f rational function f of xy by g of xy, then this degree of f by j is degree of the numerator, that means degree of f minus degree of the denominator, degree of g. So if it involves the we have product of two functions f and g, then degree of fg equal to degree of f plus degree of g. So what is the example here? U equal to x power n into sin of y by x, that we already discussed. Functions of ratios, suppose this sin y by x, e power x by y have degree 0, right? If you replace x with tx and y with ty, sin of ty by tx, that means tt cancel, we will get the same function, therefore it is degree 0. For second order Euler's theorem, right? Euler's theorem, when the given function is not homogeneous, right, but it will be converted to homogeneous by converting it to auxiliary function, then this will be applicable. If x dou u by dou x plus y dou u by dou equal to g of u, then x square dou square u by dou x square plus 2xy dou square u by dou x into dou y plus y square dou square u by dou y square equal to g of u into g dash of u minus 1. And these are the special cases. Functions like we have already discussed, f of y by x e power x by y, sin inverse of x by y satisfies x dou u by dou x plus y dou u by dou equal to 0, because these are homogeneous functions of degree 0. That means here we will get n into 0. For logarithmic function u equal to log v, where v has degree n, then x dou u by dou x plus y dou u by dou equal to n. For inverse trigonometric function, we use chain rule with auxiliary functions, is v equal to sin u or v equal to tan. Thank you.